on this computer. Okay, now guys, everybody, this today is going to be a great day for you to learn one of Mr. Kramer's favorite games. One of my favorite math games is called Target Number. And I'm going to teach you the way I play the game, which is really, really challenging. So everybody now put their hands down. I'm going to do it for them. And what I want you guys to do is this. I want you to understand that in order to play this game, you have to have certain skills. And I'll explain to you what I mean. For instance, when you play this game, you have to know something called properties of 0 and properties of 1. Now, properties of 0 and properties of 1 are a lot of fun. They are a lot of fun. So what I want to do is I want to ask you a few questions. So I want you to raise your hand electronically if you know the answer to the first few questions. All right, here we go. We're going to do 3, 5, 7, 11. Smiley face. And I'm going to go. So I don't know if you guys know what these symbols mean, but when you see a plus and a minus symbol together, it means plus or minus. Can everybody say that? Plus
or minus.
Minus. So everyone, if you see 3 plus or minus 0, on 3, what do you get?
3.
What if you have 5 plus or minus 0?
5.
What if you have 7 plus or minus 0?
7.
What if you have 11 plus or minus 0?
11.
What if you have smiley face plus or minus 0?
Smiley face. Smiley face.
What if you have house plus or minus 0?
House. House.
Exactly. So whatever you start with, the thing you start with, if you add or subtract 0, you get the thing you started with. It's actually called the identity property. Everybody say identity property.
Identity property.
Now, I want everybody right now to be looking at their own picture, the little thumbnail of their own picture. And I want you to look at yourself right now. So let's say I'm Kennedy. I would say, Kennedy plus or minus 0 is?
Kennedy.
Kennedy. Kramer plus or minus 0 is? Kramer. Olivia. Go ahead, Olivia. Olivia plus or minus 0 is Olivia. Come on, next. Go, go, go.
Teddy plus or minus Teddy.
No, no. Teddy plus or minus?
0.
0 equals what?
Teddy.
Great.
Carter plus or minus 0 equals Carter.
Carter, awesome. Drew, what about you? You have to unmute yourself. Go.
Jonah plus or minus 0 equals Jonah.
Awesome. Go, Drew.
James.
And Drew, you got to help me out with the unmute, buddy. Go ahead.
James.
Go ahead, Drew.
Drew plus or minus 0.
And you have to now say equals, and then tell me what that equals.
Equals the same thing.
And what is the same thing?
Drew.
Awesome. Awesome. Now, everybody do this for me. Ready? I want you to look at this one now. And I want you to tell me about this property of 0. This little dot means multiplication. This little dot means multiplication. So 3 times 0, 5 times 0, 7 times 0, 11 times 0. Smiley face times 0. Gabby, you give me the first one. Go. Gabby, you raised your hand. Go ahead, honey.
0.
Wait, can you give me the full sentence, please?
3 times 0 equals 0.
Awesome. Somebody else. Next one. Go.
5 times 0.
Wait, you got to raise your hand. Carter, go.
No. 5 times 0 equals 0.
Awesome. Teddy raised his hand. Go.
7 times 0 equals 0.
And let's see who else I'm looking for. Other raised hand. James. Go for it, James.
11 times 0 equals 0.
And Jonah, give me the smiley face.
Smiley face times 0 equals 0.
Now, somebody raised their hand, Leslie Dosek. I'm not sure who that is. I can't see it. So you're going to have to rename yourself because I don't think we have a Leslie. Okay, so help me out here, please. Yes, it is 0. Kramer times 0 means I have 0 Kramers. I have 0. And it's really, really important. Now, Jesse, what about Jesse times 0?
Jesse?
It equals 0.
It equals 0. Now, I have a really strange one for you. Are you ready for the weirdest one? And Kennedy, can you turn off your virtual background, please?
Yes.
Here's the next one. 0 divided by 3, 0 divided by 5, 0 divided by smiley face. So I'm going to take 0, I'm going to divide it into 3 equal parts or 5 equal parts. And I want you guys raising your hand if you know that one. And remember, raise your hand electronically. Learn how to do that, please. All right, I'm going to start with you, Jesse. Go.
0 divided by 3 equals 0.
I agree 100%. That is true. Gabby, what about 0 divided by 5?
That is 0.
And what about 0 divided by smiley face, James?
0.
And now, are you ready for the trick question? Don't get tricked. Don't get tricked. Are you ready? 0 divided by 0. Don't answer so fast. Think about this. Take some time to think about this. This is really interesting. Somebody has to have an idea for me. And I want different people to be raising their hands. If you haven't raised your hand, raise it now because I want to hear from everybody. So I've got Jesse and Gabby has some ideas. Teddy, if you want to raise your hand electronically. Who else do I have here? I have Drew. I have Carter, Kennedy. All right. So I'm going to start with you. Let's see. I'm going to start with you, Kennedy. Go.
I think it is 0.
You think it's 0. Okay. So you think it's 0. I'm going to take some other people. Carter, what do you think it is?
1 million.
1 million. Interesting. I'm gonna write that down. And we're going to talk about that in just a second, Carter. Very, very interesting. Who has some other ideas? Jonah?
I think it's infinite.
Whoa. Now, Carter, that's why I was interested in your answer, because 1 million is really, really close to infinity, right? And Gabby, what do you think? And I've got Teddy. What do you think, Teddy?
I think it's 1,000 because 3 zeros.
Interesting.
And then you just
A
add 'em.
thousand. I like your, you know what? I especially like, Teddy, your explanation. It's not 1,000, but I love your explanation. I don't like it. Jack, talk to me.
I think it's 10.
You think it's 10. And can you tell me why you think 0 divided by 0 is 10?
Because I think I've heard what 0 divided by 0 is. Well, I've heard like divided by, and I think what I heard was 0 divided by 0 was 10.
That's really, really interesting. Well, I will tell you something, guys, and I don't know if you guys have access to calculators right now. If you could go onto your iPad calculator, but if you put in 0 divided by 0, I'd really be interested in what it says. So if you have a calculator, grab it and then tell me what you get when,
0.
and Jesse, you were gonna say yours too.
Oh,
What's it say up there?
And so I'm gonna start.
Oh,
Oh,
mine says
Odd
error.
number.
whoa, wait. I got error. What was
And
another
I got
one?
error.
Mine
Error.
said not a number.
Oh my God, not a number.
Mine said
I-
error.
mine
Error.
said 0.
Mine said error.
Whoa, Gabby, let me see your calculator. Can you show it to me? Gabby, can you show me your calculator? Oh, cool. Now, Gabby, do it again. 0 divided by 0. Let's see if it's really 0.
0.
Wow. Now,
Yeah.
Gabby, I am not going to tell you to put that calculator in the garbage because we don't throw away things that are valuable. But that calculator is actually 100% wrong. So 0 divided by 0 is not 0. That is not 0. 0 divided by 0 is actually considered infinity or undefined. And I want everybody right now to draw the infinity symbol. Draw the infinity symbol and then put an equal sign with a 0 and a slash through it. If you do an infinity with a 0 and a slash through it, you will get infinity is undefined because infinity is not a number. So it's really interesting. Carter, your answer was really interesting because you said 1,000,000. When you divide something by something really, really small, the answer is really, really big. And so when you divide anything by 0, the answer is infinity. So everybody do it right now. 5 divided by 0. Go.
Infinity.
Infinity.
John. 7 divided by 0. Go.
Infinity.
Or undefined. 8 divided by 0. Go.
Infinity.
Infinity.
Or your calculator might say error. Now, what's fun is that the computer calculator, I think, says infinity. My calculator says can't divide by 0. Gabby's was the only calculator that didn't properly program the answer to 0 divided by 0. And Gabby, I'm so interested in how they could sell a calculator that would work like that. In fact, if Mr. Kramer invented a calculator and somebody tried to divide by 0, you know what it would do? It would start making sirens and it would make all types of crazy noises, and it would say, you cannot divide by 0. Okay? So if you ever see a calculator that's a crazy calculator, you know that I invented it. What about you, Kennedy?
When I went on the computer calculator, that's the one I was using. When I did 0 divided by 0, it just said error. But when I did 7 divided by 0 and 8 divided by 0, it just says infinity.
Wow, very, very interesting. See, I kind of think that it's a very interesting distinction, Kennedy, that you just made. Beautiful job. Now we're going to do the properties of 1. The properties of 1 are even cooler than 0, guys. Everybody, let's do it. You ready? Smiley face times 1. On 3. Go. 1, 2, 3.
Smiley face.
Smiley face.
Smiley face.
Kramer
face.
times 1. Go.
Kramer.
Hey.
Kramer. Infinity times 1.
Infinity.
Infinity.
Yeah, and some people might disagree with that. They might say, Kramer, you can't divide infinity by anything. But now, what about this one? You ready? What about smiley face divided by 1? 4 divided by 1. 2 divided by 1. Raise your hands electronically, please.
No, you're not.
I have Teddy first and then Gabby. Go, Teddy.
Well, has anybody ever thought that if you divide 0, you would get something in the negatives? So 0 divided by 0 could be like -0.
Whoa. Now, if there were a -0, that might be a good idea. But in fact, Teddy, if you take 0 and divide it by a number, you get 0. 0 divided by smiley face, and you get 0. But as we know, anything divided by 0 is infinite, So now, are you ready? We're going to do it again. 4 divided by 1. Who's got that? Go, Jack.
4 divided by 1 is 4.
And James, go. 6 divided by 1 is?
6.
And smiley face divided by 1 is? Everyone.
Smiley face. Smiley face.
And now let's try this one. Let's try this one, okay? What about smiley face and nobody call out? Divided by smiley face. Don't anybody call out. Please raise your hand electronically if you know. If you know. So Jesse, you're muted and unvideoed, so I don't know if I can call on you. Jonah, go.
It equals 1.
Can you explain that, please?
Because if it's smiley face divided by smiley face, then it's basically how many times the smiley face go into smiley face, which is 1.
And what about 4 goes into 4? Let's do Jesse.
What if divided by 4 equals 1?
And Drew, what about 3 divided by 3?
1. I'm going to tell you, two numbers are the same and they're divided by the same. They're always.
Drew, do you have that for me? 3 divided by 3?
1.
It is 1. And what about Kennedy divided by Kennedy?
Divided by
1.
Yeah.
1.
That's right.
Then I
And,
go into myself once.
and now, what about, are you ready for this? What about James divided by Jonah?
2.
Trouble. That's trouble. That's trouble. No. That's kidding. That's awesomeness. That's awesomeness. That's awesomeness. Now, are you guys ready to learn target number?
I know.
The first thing I'm going to do is I'm going to share with you, I showed you this about a month ago, random.org. I programmed it to shuffle 40 cards. So what I did was I took a deck of cards, and can you tell me what I eliminated from the deck of cards? Who's going to tell me? Raise your hand electronically and put your hands down first and then raise them again if you can tell me what I eliminated from the deck of cards. And there's somebody here in particular that I want to apologize to. And that is Jack. So Jack, why do I need to apologize to you for this game? What did I remove from this deck of cards, Jack?
Oh yeah.
What did I remove from this deck of cards, Jack?
Was it the aces?
Well, no, the aces are right there. The aces are worth 1 point. And can somebody help out? Olivia. Olivia, everybody listen.
Jacks.
Wait, Jack. I took Jack away. Everybody here who is a queen, raise your hand and I apologize to you. I took you away as well. I'm so sorry, queen. And anybody here who is a king, raise your hand if you're a king. I took you away also. And if you're a joker, I also took you away. So I took away, and listen to this, I took away all the jokers, all the jacks, all the queens, all the kings, and it left me with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4 times, which is 40 cards. So if you go to random.org, which is the actual site that I gave you, so I actually programmed it to give you only ace through 10 and to give you 6 cards. So everybody, let's do it again. We're gonna shuffle the deck. We got an 8. We're gonna shuffle the deck and we get a target number of 3. Now, I'm gonna copy this down for you. And I want you guys to copy down these cards. Copy down the cards that I just gave you. Let's see if I can do this. Copy down those cards, please. And what we're going to do is Mr. Kramer is going to expand this. And I'm going to circle, or I'm actually going to put a red square around what I call the target number 3. So everybody put a little T next to the 3 because that's the target number. And your job is to get 3. Now, I want you to watch one way that Mr. Kramer sees I can get 3. Are you guys ready? Everybody watch. 9 minus 8 equals 1. I'm allowed to use addition, subtraction, multiplication, or division. So I got 9 minus 8 is 1. And then the ace and the 1, watch this. 1 take away 1 is 0. And then, do you guys see the 3 and the 6? 6 minus 3 is 3. And do you see now that I can connect 3 and 0? 3 plus 0 is 3. And that is one of about 100 solutions for this set of cards. Now raise your hand electronically if you have a solution for me, and we'll go through it together. So work on it, work on it. You should be picking up your pencil right now. Everybody should be feverishly writing out different calculations, different ways to make 3. You could use multiplication, division. You could use so many different ways of getting there. And by the way, when you play this game with a friend, the first person to a solution gets to keep the 6 cards. And then you play 6 rounds with 40 cards, and then you shuffle the deck and play again. It is so much fun. I do it with my family all the time. And we try to stump each other and come up with more elegant solutions. Come on, who's got an idea? And by the way, even if you're wrong, it's kind of cool to go through that idea. So James, I want you to take me through the first one, buddy. Go ahead.
Okay, so I did 9 minus 8 equals 8.
9 minus 1 is 8. Keep going.
8 plus, I don't know why I did this. 8 plus, 8 equals 9.
Wait a minute. You've already used the ace. So
Oh.
the ace is no longer available, but you have to use all the other cards. Do you think you can get there? Now, wait a minute. What do you think you could do with 8 and 8?
Make 16.
Yeah, but what about, look at 6 and 3.
Mm-hmm.
You know that 6 minus 3 is our target. So 8, what 8 will get rid of those cards?
Oh, 8,
8 minus 8, James, equals what?
0.
Yes. And then 0 plus 3 is 3. So great job, James. You were the first one with the courage to try one of these. Teddy, go now.
So I did 9. Can I use minus 3?
Well, if you have a 3 and you have a 9, you can do 9 minus 3.
Equals 6.
Did you write this down, Teddy? Teddy, did you write it down with the pencil?
Yeah, I
Great.
did.
Now
I
look,
made
look.
a mistake.
Well, maybe we can fix it. We fixed James. Come on, let's see if we can fix it. So what was your next strategy?
6 minus 6 minus 6.
Well, that would be good, but unfortunately, if you do that, you're going to get 0, and then somehow you have to make a 3 out of 8 and 1. And that,
Okay, so I'm now gonna do minus ace, I guess.
oh, so you want to do 6 minus 1?
Yeah,
Now that is interesting. And what does that get you?
5.
Uh-oh, Teddy, guess what? What do you need to get from 5 to 3? What number do you need?
I need a 2.
You need a 2. Teddy, do you see a 2 with the remaining cards? Does everybody see it?
Yeah.
Teddy, look at the remaining cards you have, 8 and 6.
Equals 2.
What can you do with 8 and 6, Teddy, to get 2? Teddy, 8, what?
8
6?
minus 6 equals
Yes. And Teddy, there is your 2. So 5 minus 2 is your target number. You see how, Teddy, we fixed it together. So even if you don't get it right, it's okay. Now, who is next? I've got Jack. Go. Remember, raise your hand electronically if you want to share your method. Go. And Jack, I called on you, but you're muted. So you gotta help me out. Go ahead, Jack.
A minus, wait,
Did you write it down? Did you write it down? Just look at your paper. It'll tell you everything. It'll tell you a story. Everybody keep working while Jack is thinking. Come on, Drew, you have any ideas? You have a solution, buddy?
One solution.
6 minus 3?
All right, let's try it. 6 minus 3 is what?
3.
Keep going.
No.
9 minus 1.
9 minus.
9 minus 1 is what?
Is 8.
Nice.
Minus,
What, 8 divided by 8?
divided by 8.
So you're going to say 8 divided by 8. And what is that, Drew?
That is 1.
Oh my God. Now, Drew, you got 1 and 3. Are you there?
We get the 3. 1.
Oh, yes, he is.
What can you do with 1 and 3, Drew?
You can add them up.
Let's
Yeah,
try it.
multiply.
3 plus 1 is, we're 1 away. So adding's not going to get you there. Come on, Drew, you can do this.
Multiplying.
Yes, 3 times 1 is 3. You did it. You're the first one that used multiplication, Drew. Awesome, awesome, awesome. Who's going to try next? Come on, who's got an idea? I want to hear your ideas. Teddy, do you have another one you have?
No. Sorry.
Now, guys, I was thinking of something here when Drew was doing his. Oh, Jack, do you have one too?
Yeah.
Go for it, buddy.
8 minus 6 is 2. 2 plus 1 is 2 plus 1 is 3.
Now, Jack, that is true. But do you want to do the 2 plus 1 right now? Because if you get a 3 now, Jack, you still have to use 9 and 3 to somehow get to 3 with 3. So I like your approach, Jack, but why not say 2 needs a what? You know that 2 needs a 1, right?
Right.
So, Jack, can you use 9, 3, and 1 to make a 1? Is there any way to get there?
But can't he just do 9 divided by 3?
Ah, now that's the first person to use division. 9 divided by 3 equals what, everybody?
3.
That's right. And wait a minute. Now 9 and 3 make a 3. So maybe we should start again. And Jack, help me out here. Come on, we know that 9 divided by 3 is 3.
So
Now, what can we do with these other guys?
then we would do
What can you do with 8, 6, and 1? Who sees it, guys?
8, 6, and 1.
How about 8 take away 6? What do you get, Jack?
You get 2.
And what about 2 take away the ace? What do you get?
1.
And then what did Drew do earlier from 3 and 1 to get to 3?
1 time. 3 times.
Right. 3 times 1 is 3. Awesome. Kennedy, do you have a new solution for us? Jack, that was a great job. Go, Kennedy.
Could you use 3 for the power of 1? Would that work?
Oh my gosh. Absolutely. So 3 to the first power equals what, Kennedy?
3.
Okay. Now you just used the ace and the 3. So how are you going to now, in a way, get rid of these other cards?
I could use maybe 9 minus 8.
And 9 minus 8 is what?
9 minus 8 equals 1.
And you could do 3 times 1, but now you have to deal with a 6.
Yeah. Oh yeah. That
What are you
won't
gonna
work.
do? What are you gonna do with that? That 6 is kind of annoying, isn't it?
Yeah, kinda.
Who has an idea for me? Come on, James, Olivia, Carter, anything? All right, guys, guess what? I want you guys to listen to this. One of my students challenged me yesterday and said, Mr. Kramer, I found a group of cards that you can't solve. Would you guys like to try to solve it?
Okay.
Now, this is the hardest one we've done so far. Now, what happened is he started out by giving me the target number. He started out by telling me that the target number was 9. He said he drew 4 aces and a 2. And he said, Kramer, you can't solve it. And I want you guys to try. So write those numbers down. I want to see everybody using their pencil right now. In fact, I want you to be making lots of different calculations and try to solve it. If I could put my calculator right through the computer, I would give it to you if you solved it, but I can't. So Drew, I'm going to go with you, buddy.
So 1 times 9 equals 9.
That's true, but you can't use the target to create the target. You've got to only use the other 5 cards. And so if you could make a 9 with these numbers, then you could do 1 times 9. But you can't use the target to multiply by one of your cards. So Drew, that was a great try. Now, who's got one here? Wait, Jonah?
I thought of one part, but I didn't think of the other.
Okay, Jesse, I want you to pick up that
maybe
pencil.
it could
Hold on
be-
a second. Jesse, pick up your pencil and start working. I want to see you working. I want to see
got an idea.
everybody trying. Okay, Drew, you're going to go next. Jonah,
thinking my mind.
but I want you to not do this in your head. Do this on paper. Pick up that pencil. Okay, go Jonah.
Never mind.
Okay, go Drew.
So what are you gonna do?
So 2 plus 1 is 3, and then 3 times, and 1, 2, 3, and that's, and if you, and then it's like multiply it by 3, that equals 9.
Wait a minute. Hold on a second. Take me through this a little faster. No, I'm kidding. Take me through this a little slower, Drew. So you said that 1 plus 2 is what?
3.
And then you said?
1 plus 1 plus 1 is 3. And if you do 3 times 3, it equals 9.
Guys, guess what? Drew found the first solution to this problem. Kennedy, talk to me.
So you could do 1 plus 1 plus 1 is 3. And then you could do 3 for the power of 2, which is 9. And then you could do 9 times 1.
Okay, everybody right now, oh my God, I cannot believe what I just heard. Everybody watch what Kennedy just said. Now watch this. This is so cool. And we're going to learn something about powers right now. We're going to learn something about powers. So Drew's solution was perfectly elegant. Do you understand? It was pure 3 times 3. It was beautiful. Now, Kennedy, your solution is to take 1 plus 1 plus 1 is 3. Take 3 to the power of 2. Now, everybody, 3 to the power of 2 is not 6. You do not multiply 3 times 2. You do what, Kennedy?
You do 3 3 times.
So 3 times itself twice, and that equals what?
9.
9. And you use your 2 now, and what do you do now?
9 times 1.
9 times 1, or 9 to the power of 1 equals 9. Or better for you guys, 9 times 1 equals 9. Now guess what, guys? I have a third solution. Would you like to see it? Unless you guys have one. Now, James, are you trying to find another solution? How about you, Olivia? How about you, Teddy? Gabby, what about you? Did you find it yet? All right, now you're gonna love this. And I want to show you. I started out the same way as Drew and Kennedy. And I did 1 + 1 + 1 is 3. But I did something a little different. I did 2 to the power of what?
3.
And what is that, everybody? 2 times 2 times 2. Everybody go right now. Go. 2 times 2 is?
It's essentially 8.
4.
2 times 2
4.
is?
4.
And 4 times 2 is?
6. No, 8.
8.
8. And everybody, 8 plus 1 is 9.
But what about the 2? Oh, yeah, you used it.
We used our 2, and I am so excited that you opened up the idea of exponents. That was so amazing. Now, does anybody see any other solutions? Because Jack, do you have one?
Did we already do 3 times 3?
Yes, we did. That was Drew's, and that was beautiful. So, Jack, if you came up with that, that's awesome, buddy. That's awesome. Now, are you guys ready? We're going to do, oh, Gabby, do you have one too, sweetie?
Yeah, oh. No, that wouldn't work.
You know what I tried, guys? I tried adding 1 + 1 + 1 is 4, and 4 times 2 was a little too small.
Yeah, that's what I did that too at this time.
That was just a little too small.
Oh, yeah, Mr. Kramer,
Yes.
I found one.
Yes.
I actually figured it out. So you use 1 + 1 + 1 equals 3, and 2 + 1 equals 3, and you could do 3 to the power of 3 equals 9.
Ah, now anyone, Gabby, I love what you just did. But Gabby, watch what 3 to the power of 3 is. 3 times itself, Gabby. 3 times. So Gabby, what is 3 times 3?
9.
9.
And what is 9 times 3? Not everybody knows this.
27. Can I go?
If you said 27,
That was me.
absolutely. So Gabby, you got really, really close, Gabby. Oh my gosh. Really, really close.
If
So
you
now,
take it to the power, oh, but we already did.
I am going to open up a new problem. So we're going to go to our random.org, and I hope everybody goes onto that site. Oh, you guys like that one?
Dex do you?
Say again?
How much Dex do you use on your random.org?
How many what do I use?
How many decks do you use for all the cards?
Oh, it's a great question. So I programmed myself to have only 40 cards. So I programmed it to have only 40 cards each time. Now, guys, I wasn't able to do that. Can you guys write these numbers down, please? 4, 10, 8, 5, 7 with a target number of 2. And whoever asked the question, I think it was Jesse, you can actually program it to do more decks.
Wait, what's that? Mr. Kramer?
Yes.
I did find, I found 3 other decks.
You found what?
I found something to that if the target number is ace, the cards 9 to ace, 4, and 6, I have an answer for that.
Wait. Hold on a second. So you have 9, say it again, 9 to
9
8,
to
4,
8,
and 6.
4, and 6.
And the target number is 1.
Yeah.
And what is your solution, Jack?
So you would do 1 plus 1 equals 2.
Yeah, but there's no 1 here unless you make a 1. You've got to
Yeah,
actually
because
make 1.
it was actually each was the target number. It was 9. It was 9 to 8 and 4 and 6.
So what's the target number? Let's start there.
The target number is 1.
Oh, the target number was 1. Okay, great. And do we all have these numbers correct?
No, that's so 6 is 9.
So I should change the 6 to a 9?
Yeah.
Okay, anything else?
Instead of 4, it's 2.
Okay.
Well, there is a 4. So.
Why don't you just read all 5 cards to me?
Okay. Target number is 1, 9, 2, 8, 4 and 6.
4 and 6? Okay, so I'm going to write ace, which is 1, and then 4 and 6. Okay, go for it.
So 1 plus 1 equals, so 4 plus 6 is 10. 10 minus 9 equals 1. 1 plus 1 is 2. 2
What you have to do, is it addition, subtraction, multiplication, or division?
multiplication.
Well, 2 times 2 is 4. So think about another operation that we talked about. Anything divided by
That's
itself.
divided by.
2 divided by 2 is 1. Jack, that was beautiful. Now I want everybody working on the one that I just put down. Your target number is 2. Your 5 cards are 4, 10, 8, 5, and 7. And I want everybody working really hard. Now, I want you to raise your hand electronically. So Drew, I want you to do that like everybody else.
Okay. I can't. I know where that button is.
Okay, then Drew, why don't you take us through it? Take us through it, but I want you to learn how to do that. Go for it, Drew.
Oh yeah, I pressed the button.
Good boy. Now go ahead.
So 10 divided by 5 is 2.
Oh my God, what a great start. Keep going.
And 7 minus 5 is 2.
You don't, where's your 5? You've already used your 5.
Oh yeah, good point. And 8 divided by 4 is 2.
I like that a lot, Drew. 8 divided by 4 is 2. Now I have a 2, and a 7. How am I going to deal with 2, 2, and 7 to get to 2?
It's tough.
Drew, you've given us a really interesting challenge here. I don't know that that's doable, but I really, really like it. I really, really like it. So go back to the drawing board and see if you can get there.
Use all the cards. So how do you, when you start over, use all the cards?
So,
Drew, I want you to write it down with your pencil first. And when you solved it, then raise your hand electronically. Look at James. He's going at it. I think James is going to get it because he's really working at it. I see Kennedy working at it. I see Olivia definitely working at it. Carter, I can't see anymore. and Teddy I can't see anymore. But I see one. I don't know who it is, if it's Drew or Hayden. Hayden, I need you to pick up your pencil. Pick up your pencil. It is an amazing, amazing weapon. And start to connect these cards to get to 2. All the ways to get to 2. Now I've got James. James, give me your solution.
I did 17. I did 10 plus 7 equals 17.
Got it.
17 minus 4.
You have to say what it equals.
Equals 13.
Good.
8 plus 7 equals, I did 8 plus 7.
Where's your 7? You've already used 7, yes? Now, did you want to do something with 8 and 5?
I'll use 5 later. Oh, no, I didn't.
5 later, huh? Interesting. You want to go back to the drawing board?
Yeah.
Yeah, drawing board is a good place, guys. It's a good place to be. And Carter, are you working on this? Jesse, I don't see you working, Jesse. Jesse, if you were working, your pencil would be going at it at a feverish rate. You would be writing stuff down. You can't do it without a pencil. My opinion.
Okay, we'll get on this.
There we go.
What is 8 minus 8?
10 minus 2.
And now you've got a 4, and you've got 2 2s. Can you figure out any way to do anything there?
Let's see. I got a 1 there. Got a 1 there. So guys, we're almost out of time, and I want everybody to look at Mr. Kramer's board because I have a strategy that I think might work. I'm going to unmute, so everybody be nice and quiet. Now, I like to do this game working backwards. Are you guys ready to watch me work backwards?
Yes.
I'm going to write 1 plus 1 on the board. And you know that 1 plus 1 is 2, correct?
No.
Now, do you notice that 8 minus 7 gives me one of my ones? Do you guys agree? Do you guys agree?
Yes.
Yes.
Do you agree that 5 plus 4 gives me 9? And do you agree that 10 minus 9 gives me the other one that I'm looking for?
Yeah.
And you guys see how 1 plus 1 equals 2?
Yeah.
Now that was just one of literally an infinite number of solutions. I think there are about 10, maybe 20 more solutions for these cards. And I want everybody to look at what I've done for you. I've given everybody, as you saw before, a deck of cards. If you don't have cards, some of you actually, Teddy, you have a deck of cards, right?
I have these.
Yeah, look at Teddy's deck of cards. Everybody has a deck of cards, but if you don't have a deck of cards,
They don't.
Got it again.
Take the aces out. Do you take the aces out?
That's a great question. Now, you do not take the aces out. As you know, Teddy, the aces are worth 1. You take Jack out of there. You take all the queens. Sorry, Jack. You take all the kings. And Jonah, you take all the jokers out of there. So you take the jokers, the kings, the queens, and the jacks. And then you have 40 cards left. I already found mathletes cutting up these 40 cards to play with. Then I gave you so many different challenges. Look at this challenge, guys. I gave you 4 different combinations and then another 4. And on the bottom is the random.org that I programmed for you that you could generate your own cards. Now, I do need to let you know something. Somebody asked me the question. They said, Mr. Kramer, have you ever come across 6 cards that you could not solve? And here's the answer, guys. You ready? Not yet. There are 810,000 combinations
Oh, I have one. I have
of cards.
I have one that you can't solve.
Which one is that, buddy?
5 zeros and 1 1.
If we had a 0, you would be right. That would be very, very difficult. But
Right.
unfortunately, now wait a minute, Drew, maybe in the next iteration of this game, Drew, we could make the jokers be zeros.
Oh yeah, good idea.
You know what? I want to see what that looks like. But do you know that with the 810,000 combinations, don't you think you could come up with something with no solution? So here's the challenge for you guys. If you come up with one with no solution, send it to me. Have your parents send it to me, and I will try to solve it. Let's say you come up with 3, 4, 5, 6, and 7, and the target number is 9. You say, Mr. Kramer, we couldn't find a solution. And I would say, okay, I'll try to find a solution. And then I will. So I want everybody, let's count from negative 800,000 by 100,000. Are you ready? Go.
Negative 700,000.
Negative
700,000.
700,000. Negative
600,000.
600,000.
Negative
Negative
400,000.
Negative
3,000.
Negative
100,000.
Negative.
100,000.
But don't ever say negative.
0.
0, 2, 4, 6, 8, 2, 3, infinity. Infinity. Go infinity.
That should be
Guys,
like that should be our new chant. That should be our new chant. Infinity, infinity, go infinity.
what, you have to go like this though.
Yeah.
Come on, everybody go like this. Infinity, 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 infinity. Come on, Jesse, you can do it. Let's do it, everybody. Okay.
I wrote infinity like infinity times. Not
Oh
really,
my
but
God. You're going to write infinity times. That's going to be a big, big number. I'll see you guys in 167 hours. Don't go away. Bye. Bye, Olivia. Bye.